My name is William. Um, my name is William Schulba. We'll just wait for 1 or 2 minutes for people to join. Thanks. Hi, Sylvia. Thanks.
Hello.
I just said we're just going to take a minute or two just to let people join.
Hi, Steve.
But I think I'm still not able to be seen, but I can't see the visual mute. Hello.
Turn on your camera.
Hi, John. It's Chloe here. Yeah, so because we are have both panelists and attendees for this Zoom, you'll only be able to see the panelists. But
Okay.
as you've just seen, if you want to speak, you did exactly right. Just put your hand up, and we can allow you to speak.
Thank you, Chloe.
You're very welcome. Thanks for coming.
Okay, thank you. Well, I think we'll get into the workshop or the webinar here and into our agenda. We have a really packed agenda. I'm really excited about it. So my name is William Schulba. I'm the Senior Freshwater Specialist at the Islands Trust. This is a workshop that we have titled Community-Based Freshwater Monitoring and Mapping. And this is part of the Islands Trust Freshwater Footprint Project, where Gabriola is our main case study, and this work is being, I guess, embedded and stewarded through the local trust committee's official community plan major project. I would like to start by acknowledging that the Islands Trust area is situated within traditional and treaty and unceded territories of many Coast Salish First Nations. And the Islands Trust recognize deep and enduring relationships that the Indigenous people of these lands and waters, and we do hold a commitment in the spirit of reconciliation through respect and ongoing learning. From where I'm joining you from Salt Spring Island, which is in the traditional territories of several Coast Salish First Nations, including the Cowichan. I'm coming to you near the village of Wachum, which is a sacred place of gathering and stewardship of the Cowichan, and continues to be a site of cultural and cultural learning and engagement and ecological renewal, where there's some really interesting projects happening with respect to wetland restoration of the old Burgwan Bay farm. So at that, I will introduce our agenda, but I will not hazard to introduce our speakers. They will have the chance to introduce themselves. So I introduced myself, I hope well enough. And yeah, so our first speaker will be Erica Forsman from the Regional District of Nanaimo's Drinking Water Watershed Protection Program. And that will be discussing community monitoring networks in the regional district and on Gabriola. Following that will be Ali Badger from the BC Conservation Foundation, and Sarah Hardy will be supporting from the Ministry of Environment and Parks on community flow monitoring networks. And So that'll take us to about 4:45, and then from 4:45 to about 5, before a 5-minute break, we're going to have a discussion from Sylvia Brosso from GW Solutions, who is the consultant on this project on Gabriola Island freshwater resources, which was called sources, hazards, and monitoring options. And then following that, we're going to have a moderated panel discussion, and at that time we'll ask, we have some questions that we have brought forward to ask the panel, but also there is a question and answer button on Zoom here. So please feel free throughout the presentation to provide your questions in there. And we have our wonderful Islands Trust staff in the background here compiling those questions, and then I will be moderating that panel discussion, and I will bring your questions forward, and I think that's probably the best way to handle them. Yeah, so without further ado, let's stay on schedule. So yeah, next up is Erica. Thanks so much for joining us.
Thanks so much, William. It's great to be here. I'm just gonna share my presentation screen here, and somebody can give me a thumbs up once I accomplish that. 1 second. There we go. Is that working for you guys? Yes. Thumbs up. Okay. Sorry, I don't use Zoom very much, so always, there we go. Perfect. Great. Well, yeah, thanks so much for inviting me to be here, you guys. Excited to be talking to you today broadly about community monitoring networks within the RDN, and narrowing in a little bit to some work that we do with our partners over on Gabriola and with Islands Trust. Just to introduce myself, yeah, my name is Erica Forsman. I've been with the Regional District of Nanaimo for about 2 years now. I head up the Drinking Water and Watershed Protection Program here, and I will begin the presentation a little bit with an introduction of what we do in the Drinking Water and Watershed Protection Program, because our mandate is pretty broad and we have a lot of different program areas. And then I will get into what we kind of refer to in this program as our sort of data to action cycle. So kind of looking more specifically at some of our groundwater monitoring programs, as well as our surface water quality monitoring programs, and how we kind of collect data in those programs through partnerships and various modes, but then how that feeds into reporting and then actually the action around that. So all of this, we really kind of hope, feeds into sort of water resiliency across the region. And it's important, I think, when we talk about water resiliency, that we're speaking to both water quantity and quality. So kind of how those two fit together. So I think I'll start here just providing a little bit of context around, oh, sorry, can you guys see this thing on the top of the screen? I wonder if I can move that. Anyway, I'll just continue. So just a bit of a context about the Regional District of Nanaimo, just because I think it's important to sort of situate the work that we do across a very broad land base. And I chose this map here today because it doesn't really include any jurisdictional boundaries on it. What this map is really showing you is the overlaid aquifers across the region. Those are kind of in the green, those green blobs all over the place, as well as the those orange lines there are these larger sort of watershed basins that the Drinking Water and Watershed Protection Program kind of situates our work within, and how we think within that program our boundaries are, so to speak. So I will note here, if we're looking more broadly across the region, how we sort of characterize our watersheds here, fairly short distances from mountaintop to sea. Generally, a lot of those mountaintop areas in the upper watersheds are managed by private managed forest land. As a result, the streams are fairly flashy, but it means we have a really amazing diversity of aquatic ecosystems. And as you can see with the green there, really complex groundwater aquifers. Across the region, I think we have about 22 mapped aquifers thus far, but those boundaries are always being remapped and renegotiated as we get more information through various monitoring networks. So multitude of community water systems. So in terms of where people get their water from, it's incredibly diverse. Some folks are on municipal systems, some on small water provider systems, and many folks just relying on private domestic wells for their drinking water. And then just to situate ourselves today on Gabriola Island. So we kind of characterize Gabriola Island as Water Region 7. That's sort of the name we give that place. And then within Gabriola, 2 mapped aquifers thus far, 709 and 706. So the larger one there is 709. But, as I said, as new information comes forward, the mapping of aquifers is always changing as science evolves. So to sort of meet this complexity across the region, the Drinking Water and Watershed Protection Program was established to kind of create sort of an avenue for meeting as a convening body, essentially, to inform local decisions and that need to coordinate across jurisdictions. So really high level, some of the program goals, protecting and managing, restoring ecosystems and watersheds, safeguarding water sources for sustainable drinking water supply, also doing work to increase water use efficiency and optimize infrastructure, also looking at fostering social, cultural, and recreational enjoyment and values in watersheds, and then last but certainly not least, mitigating and preparing for climate change. So that, again, speaking to the resiliency of those water sources. So how do we go about that exactly? So I know it's a broad and lofty goals, but through the Drinking Water and Watershed Protection Program, our work is really guided by a 10-year action plan. We're kind of halfway through this particular action plan. It was developed in 2020, and this plan outlines sort of program areas through water awareness and stewardship, so a lot of education campaigns and working with community groups on the ground, water information and science, which I'll be really drilling into today a little bit through some of our monitoring programs, and then where that can feed into supporting science-based decision-making around land and water use planning, and that's really where our water-centric planning and policy support comes in. And I'll draw your attention here, I think I can do this on the screen, this lovely river running through all of those program areas, and none of our programs exist in sort of a vacuum of working alone. Everything we do is through collaboration, really, and working with various partners across the jurisdictions. So I'll bring us here to our data to action sort of cycle that we work within, particularly in our science and monitoring programs. And I think really important to situate ourselves here when we talk about water monitoring across the region, because data collection happens in various ways, but always important to kind of keep an eye on how we are reporting and sharing that data, and how that feeds into actions, whether that be stream restoration and enhancement, letting people know across the region what's happening on their aquifers and streams through education and outreach. Some of this happens through policy development, licensing and permitting. So it's quite broad, but all of our actions that we do within our monitoring program is really done through keeping an eye on this data to action cycle. So for the purposes of today, I want to sort of highlight on 2 areas where we do water monitoring in the region. I know that Ali is going to speak a little bit to stream flow monitoring, but I'm going to kind of highlight in here some of our groundwater monitoring in terms of hydrometrics. And then also I'll touch on some of the work that we do with our surface water quality monitoring program, so looking at water chemistry on surface for the surface water bodies across the region. So our volunteer observation well network is our main mode of monitoring groundwater levels across the region. So the volunteer observation well network was established really with the intention of expanding groundwater level data collection beyond what's seen with the provincial observation wells. So you can see on that map there, the provincial observation wells are those little green triangles, and we really work to fill in the gaps there with all of those orange triangles across the region. So through this program, we have 31 private well owners have volunteered to have groundwater level monitoring equipment, also known as pressure transducers, installed in their wells. And these pressure transducers, they measure water level, record data level every 15 minutes, and then Drinking Water and Watershed Protection Program staff go out and they download about 3 to 4 times a year to capture what is being recorded on those loggers. I'll also note that about 14 of those loggers also measure conductivity. So that's looking at things like tracking saline intrusion, so on some of our more coastal wells, so that we can track a little bit of information about water quality in those wells in addition to levels. So this program, just kind of going back, that's the expansion of monitoring wells, was established back in 2013. And over the years, we sort of expanded that network to fill additional gaps as reporting has made some recommendations on this. So in terms of site selection and setup, the equipment was, as I mentioned, was installed in pre-existing private wells. So these are well owners like many of you on Gabriola who are, just pumping water off of a well that you manage on your own property, which meant that there was no need to drill new wells for monitoring equipment. But it does mean that this is really a program based on collaboration with residents across the region. So to establish these sites, letters were mailed out to residents and well owners in some priority areas, and the sites were really selected based on several factors. So some of it was about willingness of partners, which was a really considerable one, but it was really looking at where those gaps were across the region, where there wasn't monitoring happening with those provincial wells, and then recommendations about where data gaps needed to be filled. So installation, so yes, then sites were ground truths for viability. So this kind of comes down to ease of access, getting in a large truck with a crane to install equipment. Also for staff safety, for our RDN staff to be able to go out and actually do those well downloads. Well construction had to meet best practices to be a contender to join this program. And also wells needed to have an availability of well records to determine the aquifer source, well depth, and the static water levels. So how and when data is downloaded. So we go out, as I mentioned, 3 to 4 times a year. We use a laptop or a Bluetooth. Data is downloaded with a directory read cable. And then while we're at the site, we take manual water level readings as well, which really helps to coincide with the logger reading for data verification. And then I'll also mention that if a conductivity logger is installed, calibration for that is then completed ideally every 6 months on those sites. So what is it that we record? So the pressure transducer measures the water column above the logger. Every 15 minutes, we are kind of revisiting that every 15 minutes to maybe change that. But up until this point, that's kind of how we've installed these. And then barrel loggers are also installed, which are used to compensate for atmospheric pressure in these sites. That manual water level reading gives a depth to water. And then what this ends up producing is a level of water as a below ground hydrograph. So you can kind of see this here. This is one from one of the provincial observation wells, but it really gives us the seasonal sort of water level reading as we go up and down through the seasons in that particular part of the aquifer. So just a few considerations about this particular program to note. So really key, as with many of our monitoring programs, that establishing partnerships is essential. We really can't do this alone. So thinking through, connecting with stream keepers or stewardship groups, and in this case, private landowners. Funding is also a consideration. So setup for these sites is quite costly, but then ongoing funding and long-term funding is essential to make sure that you can maintain the equipment on these sites and upgrade as needed. And then also a big consideration is making sure that you have long-term program capacity. It's noted that you really do need between 6 and 10 years of data to really begin to develop any robust trend lines when you're doing analysis. So you can't really do much of a snapshot to really be able to see where the trends are headed. So also important to identify, why are you monitoring? What are you hoping to accomplish? And how will these data be used? So just to jump in here, so some of the ways that we use this information and how we move from collecting data to reporting and then into action. So where can we actually see this information? So annually since 2020, we publish a pre-summer groundwater level analysis for observation wells across the region. And this brings together both data sets from the provincial observation well and the RDN's volunteer observation well network, which really helps to provide this sort of snapshot of conditions ahead of the summer season. We usually take this to our board of directors in June so that we can make decisions going into the summer season about kind of what the outlook could potentially be. So we share with municipal improvement districts, small water system staff, and really hope that this can guide some operational decisions and support and inform communication approaches across the region. So just looking at this here, this is from the report that we published last year. This is Volunteer Observation Well 8 over on Gabriola Island. So we published 2 different graphs as a part of this report. So this is the linear trend showing static water levels. So you can see it stretches back all the way to 2013 since that observation well was established, which helps us establish that trend line there. And you can kind of see it's going slightly down over the last 10 or 11 years of collecting data on this particular site. We also publish in the report the seasonal static water level, which is useful to kind of dive into comparing year by year and where you may stand at a certain point in the year to be able to make some predictions about how you may want to adjust some management of that particular well or aquifer. So you can see 2024 pretty much in kind of average as we were reporting out last year. So you can kind of look forward to seeing this report coming out in the next month and a half as we kind of go out and get all those downloads done and are able to publish this information. So then moving into that part of the cycle that we kind of refer to as action. So where can this go? Well, today we entered into stage 2 watering restrictions across most of the region. So this kind of data can really inform considerations about how we approach communication and some things like that to ask people to reduce their water use. And I will note, I put on here, the BC provincial drought map. Drought ratings across the province are largely informed by stream flow, but we do know through very many studies across the region that surface water and groundwater are very much connected in a lot of streams. So asking people to reduce their use of water certainly can have an effect on stream flow in certain parts of the region. So another action where this can feed into is about public education and knowledge sharing. And I think this is an important one as well. We distributed this publication to residents on groundwater across the region last month. So we mailed this out to about 36,000 residents in the RDN, and I hope some of you folks over on Gabriola received it. And so really the idea of this was to communicate monitoring results and highlight water level trends and aquifers across the region, but allowed people to kind of drill down and access some of that information about their own particular aquifer. And really what we were trying to tell here is some compelling stories that would connect people to their groundwater source and show where monitoring can tease out those important stories about that water source and what their connections to it are. So I know I'm kind of running short on time, so I did want to touch as well on some of the surface water quality monitoring that we do. Our community watershed monitoring network it's a program that was really started with the goal to increase water knowledge and understanding of surface water quality across the region. So this started way back in 2011 and was really a good example, I think, of a program designed with partnerships in mind. So it was designed with the protocols and methods that align with provincial standards, really in partnership with the Ministry of Environment and Climate Change Strategy. We kind of took the lead on a lot of the coordination of the program, but then, the boots on the ground streamkeeper volunteers, and then also bringing in private forestry to contribute to the program as well. So the sites for this program were selected again to fill those data gaps. So, getting more fine-grained information across the region to allow us to make better science-based decisions. So in this program, we have 2 sampling periods. So we sampled during times when we see that streams are more stressed. So during those low flow, the summer low flow, and then also the fall flush. So after we get that really big first rain event of the year, and we sample for 5 consecutive weeks. So volunteers are out there, we call it the 5 in 10 kind of approach. So over, I'm messing up kind of the way we talk about it. So 5 in 30. So we call it the 5 in 30. So 5 samples over the course of 30 days is the approach there. And then, so all data is entered and stored publicly. It's publicly accessible on the provincially managed EMS database. So folks can go in there and download that data. Planners can use it. Landowners can use it to make decisions about and understand better kind of what's happening on a stream that may be adjacent to them. So we train volunteers with equipment use, and so they're ready to go out there and gather the data. And generally, we're kind of out there, and kind of this was last year on 38 streams across the region at 67 different sites. So really, really broad ability to monitor streams across the region through this sort of collaborative effort. So this just shows you kind of all the different partnerships that are involved in making this program run, and really underscoring here that partnerships are really key to making programs like this work. With community stewardship groups, boots on the ground, collecting the information, the Drinking Water and Watershed Protection Program here at the RDN, really coordinating it and funding equipment and providing technical support, and all of it really going into supporting project prioritization, land use planning, funding applications, and awareness and stewardship. So in terms of what we actually sample for, we look at turbidity. So that's those suspended particles in the water column. And this can be a link to things like erosion, contaminants, and stormwater influence. We also look at water temperature. This is really important for looking at, aquatic life guidelines for coho rearing, for example. So can look at that. Dissolved oxygen as well, of course, supporting aquatic life. So important to monitor where that is at. And specific conductivity, which is not really outlined by the province as having a specific kind of exceedance, but it can provide us a little bit of information, additional information, to explain other results that we're seeing on these streams and begin to target a restoration action on those streams. So in terms of where we're sampling, I include this because I think it's really important, first of all, to acknowledge all the various streamkeeper groups that are involved in this program, but also emphasizing that through those partnerships, really wide geographical range of streams that are able to be monitored through this program and through this method. So then in terms of data analysis and reporting, so we report annually to streamkeepers, local governments, and residents. And we put together these box plots that really work to compare current year of data collected to previous years. So you can kind of look at the data and see how things may be changing, specifically in a specific year. And then after 6 years of sampling on a particular site, we're able to develop trend lines. So we can kind of see if things are improving or degrading, which can give us a better idea of where we need to target restoration actions. And then in the last few years, we've also created basin delineations for each site. So mapping to kind of upstream of monitoring sites so that we can better communicate where there may be influences on a stream that could be contributing to those water quality results. So then into action. So again, we provide a lot of stewardship support to kind of give folks the tools to use this data to move into two different forms of action. So we provide stewardship seed funding as a sort of small grant funding program where stewardship groups can access up to $10,000 a year for different types of restoration and enhancement efforts. But really, the idea here is to empower folks to use the data they collect to move into community-based actions that we can support through these programs. So I'll just leave us on, again, this data to action cycle, because I really think it's important to emphasize here that action does occur at all levels. So, you know, that includes stream keepers, environmental stewards, First Nations, local government, private industry, and it's all folks on the land that are contributing to you know, increasing the quality and quantity of water that we see on those streams. And I'll also emphasize through this sort of area about in terms of reporting, it's really essential to ensure that information is publicly available, which can then in turn promote collaboration and transparency for that common goal of increasing watershed health. And again, I think important to also emphasize that funding is essential here as well to then support a lot of these actions. So really sort of all the support that's required in all of this data to action cycle that the Drinking Water and Watershed Protection Program has some influence over. So yeah, I'll leave it there. Sorry, I went over time a little bit, went through the end of those slides pretty quickly, but just trying to leave some time for the other speakers. But yeah, happy to take questions when we open up the panel later. So thanks, William.
Yes, thank you so much for that presentation, Erica. A lot of great information in there. I know I generated a few questions of my own when you're speaking, and just another note that this presentation webinar is recorded, so those who are attending can go back and revisit Erica's presentation. So we will move on swiftly to our next speakers, speaking about community flow monitoring networks. And I see that Ali is on the screen. And so without further ado, I will leave it with you. Thank you.
Okay, great. Thanks, William. Same thing here. I'm just gonna share my screen. Looks like I just had to put in a request to share. There we go. Okay, and same thing, if I could just get a thumbs up that everyone can see my screen here, that would be great. Awesome. Okay, great. Well, hello everyone. Thanks so much for inviting me today and for this opportunity to speak to you all. So, as William said, my name's Ali Badger and I'm a biologist with the BC Conservation Foundation. And so today I'm here to tell you about the sort of stream flow or surface flow monitoring side. So the quantity monitoring, water quantity monitoring, as well as a program that I lead called the Community Flow Monitoring Network. So in case you're not aware of who we are, the BC Conservation Foundation is a not-for-profit. We have 3 offices across BC, and our Aquatic Research and Restoration Center, which is where I work out of, is based in Nanaimo, and we work on a variety of projects across Vancouver Island, all kind of related to fisheries research, as well as aquatic ecosystem restoration and monitoring projects. So the Community Flow Monitoring Network is a program that we launched in 2022. And the aim of this project is to support and enhance hydrometric or flow monitoring that's being conducted by community streamkeeper groups, other ENGOs, and First Nations across the sort of east coast of Vancouver Island region. And this is very much a collaboration between BC Conservation Foundation and the Ministry of Environment and the sort of provincial hydrometric team. Sarah is my colleague from the province, and she'll be sort of talking later on. And we're also working with local and regional governments, like the Regional District of Nanaimo, to sort of look at regional priorities for enhancing community-based flow monitoring and also how our program can potentially complement some existing water monitoring efforts that exist, like the Community Watershed Monitoring Network that Erica mentioned. So the kind of overall high-level goals of this program are, 1, to create and empower stewards for protecting stream flow and fish habitat. And this is kind of that goal that my biology perspective brings in. But more specifically, we're trying to improve community-based flow data collection so that it meets government standards, and then make the data from the community flow stations that we support more accessible. And we decided to kind of take this coordinated network type of approach in order to bring together groups all across the Vancouver Island region that are interested in flow monitoring or were possibly already engaged in flow monitoring and needed support. So before I get into some more of the details of our program, I thought it'd be helpful for anyone who's not really familiar, just to kind of take a step back for a moment and provide a bit more context on what flow monitoring actually looks like and why it's important. So when we talk about monitoring flow, we're essentially talking about monitoring the amount or the volume of water that's flowing through a stream over time. And this is an incredibly important part of any water monitoring effort. So flow data can complement and help with interpreting water quality. It can also be used to help kind of track the impacts of climate change at a local scale. And along with this, it can help us to better understand how we can manage sort of increasing and often competing demands for water use. And with our growing communities, we can track changes in natural flow regimes, often due to development and urbanization. And flow can be a limiting factor for aquatic habitat, and environmental flow needs are an increasingly important conservation issue. So when we look at flow monitoring stations on Vancouver Island, many of you might be familiar with Water Survey of Canada, which operates flow stations on sort of larger rivers in collaboration with the province and their provincial hydrometric team. So this would be the BC sort of fed stations here on the graph. But community stations actually account for about 25% of all hydrometric monitoring stations on Vancouver Island, and they actually make up the majority of active stations that are monitoring small first order watersheds. It's about 56%. And if you look at the many thousands of streams on Vancouver Island, the large majority of these watersheds are actually small first and second order. And many of these small streams have had sort of that have historically supported valuable fish stocks and been subject to intensive water use have had little to no historical flow monitoring conducted. So this really means that these community efforts are substantial and quite important for monitoring many of these streams that would otherwise be unengaged. And I will note that this data is from 2022, which is the year that our flow monitoring network program started. So there's definitely more community stations now that we've helped to install, and there's also likely more government-run stations as well. So despite sounding pretty straightforward, stream flow is actually quite a complex parameter to monitor for. It's really not the type of situation where you can kind of, drop a data logger and then just come back and check it every once in a while. There's a lot of hands-on work involved. So in order to calculate flow, which is also known as discharge, you need to really know three different parameters. So you need to know the speed of the moving water, which we also call velocity. And then you need to know the total amount of water in sort of a two-dimensional space. So in the image here, you can see there's sort of the width or the width as well as the depth. And that would be sort of if you took a slice of the stream, the way the image sort of shows here. And so with those two things, that sort of area calculation and the velocity, you can see on the image here, the equation, if you have velocity and area, you can get discharge, which is equal to volume over time. But as you can imagine, the depth and the width, as well as the speed of the water in the stream are always constantly changing. And so there's instruments that we can use to kind of assess all of these parameters at a given time. And this is what we call a discrete discharge measurement. And here's some examples of our volunteers kind of just doing that here. But there isn't really an instrument that can monitor all three of these parameters all of the time in order to collect this discharge or flow data on a continuous basis. So the general approach to being able to monitor flow continuously is that we assess just one of these parameters over time, and that is water depth. So our kind of typical community gauging station looks similar to this image here, and it usually consists of a data logger that records the water level. And it uses a pressure sensor, so we'll also need a barologger nearby to record barometric or atmospheric pressure that we can use to compensate our water level data. And then we also usually have a staff gauge or some kind of stage reference point, and stage is just another term for water level. We also usually have benchmarks. So these are reference points that we survey in twice a year to ensure that the station is kind of stable and that our logger and our staff gauge aren't moving. And then the other important feature of our of our gauging station is the control point. And this is essentially sort of the sum of features that are downstream of our gauging pool that regulate the sort of water level and flow in that pool. And this is related to the kind of energy and resistance of the system. And this is usually it can be something like a natural riffle or more of an artificial structure like a weir. And so because we can only monitor that one sort of water level parameter continuously, there's quite a bit of back-end work that goes into establishing a flow station because we have to turn that water level data from the logger, we have to turn it into discharge or flow data by sort of going out and collecting those discrete discharge measurements over time and then pairing that with our staff gauge or our stage readings. And we have to turn it into flow data because that's ultimately what we're interested in. And so we do that with something called a rating curve. So we'll go out at least 6 times per year, collect those discharge and stage measurements, and then we can kind of plot those measurements together, and we establish this relationship between that stage and discharge or the water level in the gauge pool and the flow rate of the stream. And this takes a lot of time and technical experience to sort of build these rating curves, which is a really important aspect of our collaboration with the province, because we definitely benefit from their expertise in this regard. And then once we kind of have this rating curve, we can translate the raw level logger data into discharge over time. And so this graph here just shows kind of an example of a time series from one of our sites. So this would be discharge on the y-axis and then time on the x-axis. And you can see all these little sort of boot prints down below represent where our volunteers have gone out and done site visits. So as you may have gathered, like I said, there's definitely a lot of effort required in actually operating these flow monitoring stations. And so kind of where we come in with the flow monitoring network is that we try to remove some of the barriers that folks will face getting into flow monitoring. So we're a very hands-on program. We offer field support as well as equipment loans, and we facilitate equipment sharing. Some of the equipment involved in flow monitoring is quite expensive, so it makes sense if groups can kind of share equipment, and not, every group that wants to monitor flow has to purchase their own. So we'll go out and we support site visits with volunteers until they feel comfortable and kind of confident with the instruments and equipment to go out and be able to monitor independently. We also have a standard operating procedures, and we've also published kind of a whole set of other resources that are available to anyone on our project website. We also have network-wide meetings and we do training workshops where we bring people together. We actually hosted our first community flow monitoring network flow regatta last summer, and that was a really big success. And then in addition, all the data collected by the groups that participate in the network with us is shared directly with the province and housed on their central hydrometric database called Aquarius. So as I said, our kind of strong partnership with the province is a really major asset to this program. So in addition to their technical support, kind of helping us work with the data and building rating curves, all the data that's collected as part of this project is professionally reviewed, graded, approved, and then ultimately published on Aquarius, which is a website that anyone can access. So it means that the data is really accessible and that end users can be really confident that it is reliable and, defensible quality flow data. And so this is kind of just outlines our data review process and the sort of approximate timeline of how it works. And you can see that there's feedback from the province to BC Conservation Foundation. So as I upload the data, I sort of give an initial check, and then the province goes through and will provide feedback on any data submissions, things that need changing. etc. And then both the province and BCCF, or BC Conservation Foundation, we provide feedback directly back to the volunteers, and that's not necessarily just through training and workshops, but really we're providing that kind of on an ongoing basis as soon as we can, kind of after we've received the data submissions. And so here's a map just to kind of give you a sense of where some of the currently active stations that we're helping to support are located. So, and then on the right here, these are the community groups that we're partnered with who operate these stations. And we currently have 9 active stations located between about Courtenay and Nanaimo. And some of these stations have been collecting flow data for many years prior to our program. And some of these are brand new stations that we've helped to install over the past couple of years. The 3 stations you'll see in Nanaimo are new. I think Departure Creek was installed in 2023, and then Wally Creek and Caudle Creek we just installed last fall. And really by bringing together kind of all these different groups around the region and creating this coordinated network, we've really been able to not only facilitate more stronger data collection, but also really kind of foster that sharing and collaboration aspects as well. So in summary, you saw that we had 9 active stations, and we have at least 2 kind of more planned for this year. We're actually planning to install a new station in Wackwam on Salt Spring Island that William mentioned earlier in partnership with the Stakea Learning Society. And Erica mentioned the importance of the sort of long-term nature of having these long-term data sets for things like trend analysis. And this is really true for surface flow monitoring as well. So a big accomplishment sort of recently in the past year or so of this project is that all the data that we've collected from the community stations is now available on Aquarius. And this includes many years, in fact, decades of historical data across all the stations. As I mentioned, some of them were kind of monitoring before becoming involved with our programs. We've been able to go through and actually look at all that data and make it available on Aquarius, which is really exciting. And we're trying to work with our partner groups kind of now on how we can start to use this data to inform conservation projects that kind of align with their monitoring goals. Every group has sort of different goals and reasons behind why they want to collect this data. So these types of projects could be hands-on restoration type projects, or just using the data to sort of advocate for watershed protections. And we have a few examples of sites where we've been able to share data with different levels of government to help inform, other projects they may have, often related to fish passage. So things like culvert upgrades. And we've definitely seen a strong demand in this program by community groups and First Nations. And there's a lot of enthusiasm really behind flow monitoring and collecting this data, which is great to see. So for example, we've had over 1,000 volunteer hours since 2022. And we are hoping to expand. We have a lot of interest from kind of groups all across the East Coast, from Victoria and the Gulf Islands up to Campbell River. But we are a small team, so we can kind of only grow, as our program budget and the staff capacity will allow for. And so because of this high demand, we do have limited capacity for new involvement, in terms of taking on new stations, kind of beyond our current commitments this year. But if folks are really interested, there's certainly opportunity for involvement in things like training events, and we're more than happy to share resources like our standard operating procedure with anyone who's interested, and we're also very happy to discuss future involvement. Okay, so thanks very much. I will note that we have a project website, just CFMNVI, or Community Flow Monitoring Network, VancouverIsland.com. And you're also welcome to email me, but I'm just going to pass it off to Sarah. If you're ready, I can stop sharing here.
Yes, I'll try here. Can everybody see? Oh, no. Can everybody see my Good to go? Okay, perfect. Thank you. Yeah, thanks, Ali. That was a wonderful overview of the network. I'm Sarah Hardy, a hydrometric specialist with the Provincial Hydrology Program based out in Nanaimo as well, and I work with Ali and volunteers across the island. And the provincial role is primarily based on mentoring and helping folks build up the skills they need to measure stream flow. Additionally, for the Flow One program, we do also provide support for data review, which Ali went over, which is a very large and often overlooked, but one of the most important pieces of the monitoring puzzle. So many folks are keen and able to get out collecting field data, like installing water level sensors in the stream and taking discharge measurements, but that's really only about a quarter of the actual work that needs to be done. The beast really is in data review and all the work behind the scenes to produce reliable streamflow data. And this is where many monitoring programs kind of break down or find difficulties. Often you'll see raw data just sitting on someone's computer for years and years without ever being reviewed or available for use. So data review is certainly something that should be discussed at the beginning of every monitoring program, who will be doing it and using what tools, as well what quality of data that you'll be aiming to answer the questions you've identified for the purposes of your monitoring. So the provincial risk standards, it's shown on that bottom left corner. It's a really great tool for setting the scene for this and also detailing the standard methods for streamflow data collection and review in the province. I won't get too far into this because Ali did actually cover this, but basically we were talking that streamflow is kind of difficult to measure compared to some other water parameters like water quality. And that is basically because we're not actually measuring it directly, we're modeling it. So instead, we're measuring that water level or stage over time, and then taking discrete water level and discharge measurements, and then creating the stage discharge relationship based on mathematical equations, and then producing a discharge or streamflow data set that often looks eerily similar to the stage data set. But anyways, how stage gets transformed into discharge is sometimes a little bit magical. Data is often given to us freely without explanation, and anyone who has tried to do this knows how difficult it can be because streams are highly dynamic in variable places that are constantly changing. So uncertainty seems to be kind of everywhere in hydrology, but really just want to stress the key is to have folks that are knowledgeable in hydrology and are familiar with the stream sites themselves to help produce this data if you're going to be doing it. So once you do have surface water data, groups are often interested in making their data more publicly accessible. So the province is able to share hydrometric data through a few different platforms. It generally requires that you submit a standard data sharing agreement with the province. This also outlines that the data is shared according to the BC Open Information and Open Data Policy. There is further information available on what that all entails, but essentially, once that data is available, it can be accessed and used by anyone. The two different places that the data is available is on the Aquarius time series that Ali also mentioned, and also Erica did as well, on the real-time water data tool pictured on the left, and also on the BC data catalog. So there's a fair bit of information available at the link at the bottom on further details about these platforms, as well as on the agreements and the policies for anyone that might be further interested in this. So we're just going to have a bit of a closer look at the Aquarius time series, or the real-time water data tool. It houses all sorts of water information, groundwater, surface water, snow, and anyone can access this data. For streamflow data, it does house information in chart and table forms, and so there's lots of different ways you can use it. A bit of a disclaimer that not all of the data on here is reviewed, so there's certainly varying levels of quality in the data available on the site. So it's really imperative to check whether the data has been reviewed and graded before using it. And then just to wrap up quickly, just wanted to provide a bit more information about our program. And our primary roles are basically to manage the relationship with the federal government for the Water Survey of Canada sites, as well as we also have our own provincial hydrometric network that we monitor. We also publish operational standards for hydrometric data production and are always happy to chat about those. And lastly, which is really important for community groups, is that we provide training, mentoring, and equipment support for data collection and review. So we are available to come out to sites, do virtual workshops to provide training on how to collect field data or how to do data review. We can scope and surveying, and are just generally available to continue mentoring and building up skills and support over time for volunteer groups. So if there's any further questions, please feel free to contact me anytime at my email below, and thanks very much.
Oh, there you go. Great. Thank you so much for the presentation. I have several questions that came to my mind when the presentation was happening, and that reminds me to invite anyone to use the question and answer function on Zoom to submit a question at any time. And also, if you belong to a community monitoring group on Gabriola or some other island, you can also just plunk that into the question and answer if you'd like, just to introduce the group that you're involved with. And so without further ado, I'm going to turn it over to Sylvia. Thank you.
Thank you. So Chloe's going to set up the PowerPoint for me there, and I'll ask her to forward the slides. Can you hear me okay, volume-wise? That's good? Okay. All right, so that was so interesting to see the breadth of different types of monitoring activities and approaches that are being undertaken in the regional district of Nanaimo and Eastern Vancouver Island. And it's exciting both in the way local governments and provincial governments are facilitating data collection and understanding about water resources within their community. So to focus in somewhat on the Gabriola situation, I wanted to talk more about the water resources, some of the types of hazards and the monitoring options that could be implemented on Gabriola Island. Oops. Chloe, do you want to restart the presentation and forward the slide? All right, so I wanted to briefly give us an understanding, or my objectives for this workshop or this part of the workshop was for us to develop an understanding of how freshwater monitoring can improve our understanding and management of freshwater resources, to talk about some of the hazards and challenges facing freshwater sustainability on Gabriola and Gulf Islands and Vancouver Island, including things like aquifer stress, climate change and seawater intrusion, give an overview of the current net monitoring networks that are in operation on Gabriola Island, and talk about monitoring data gaps and opportunities. And this will bridge us into a larger discussion with the group and attendees present here today. Next slide. So this workshop is being undertaken as part of the Islands Trust Freshwater Footprint Project, which GW Solutions has been involved with, working with Islands Trust and as a component of the Gabriola Island Official Community Plan revision process. So the project has a technical component, which is involving a compilation of existing data, updating water balance for the island, and evaluating aquifer stress and vulnerabilities to the hazards that we've talked about, what I've already mentioned. Another piece of it is to try to look at what would it entail to develop an assessment of the water footprint on the island, which could be a more holistic measure of sustainability and provide us with indicators, thresholds, or objectives that we can work toward to ensure protection, restoration, and maintenance and sustainability of our freshwater ecosystems and water sources. And then an important part is to have community involvement in the development of this methodology and to bring folks along into the understanding of what the risks that we face in terms of freshwater sustainability on the island and the opportunities that exist. So that's what this workshop is the first of 3 workshops that are to be undertaken as part of the project. Next slide. So when we're talking about freshwater resources on Gabriola Island, the primary water source for water supply, including domestic, commercial, and industrial use, is from drilled wells. There's more than 2,700 registered wells in the GWells database for the island. And the water source for the island are aquifers that are consisting of fractured sedimentary bedrock. So we're talking about sandstone and shale deposits. These types of aquifers are associated typically with fairly low well yields in some case, or low to moderate well yields, and they have limited storage capacity. So it affects the productivity of the wells and availability of water for different uses. The water is stored within fractures and faults and vacancies within the rock itself. And you can have both contact surfaces between sandstone and shale beds, or as I said, gouge or fractured zones that will hold water and transmit it to wells when they're drilled into those deposits. The recharge is both from diffuse precipitation over the island, the footprint of the island, as well as from focused recharge into these types of geologic features like faults that are where they're exposed on the land surface, or where they underlie wetlands or other drainage features. And all of the water on the island is essentially a freshwater lens that overlies saline water, the surrounding ocean and below the island. And so the aquifer also is overlain by fairly thin layers of soil and overburden materials. So they're quite vulnerable to contamination, and because of the low yield and limited supply, can be vulnerable to climate change as well as to seawater intrusion. Next slide. In terms of surface water, most of the watersheds on the island are very small, 0, first and second order streams that drain to the coast. There are some wetlands and small lakes. As I understand, many of the streams are ephemeral, they flow seasonally and they dry up in summer. And of course, they're vulnerable to changes in land use and drainage patterns, climate change, and contamination from runoff and eutrophication. Next slide. So when we think about groundwater management, one of the, rather than aquifer scale, it's sometimes more useful to think about groundwater regions. So there are 11 groundwater regions which have been established for the island, which roughly correspond with watersheds or drainage basins that drain towards different parts of the island. And so you can see that there are some larger central regions and then smaller ones that border the island. And those are used as the base unit for evaluation of water availability, supply, and impacts, and other analyses that we're undertaking. Next slide. This map just gives an overview of the registered wells on the island. So you can see that there are areas of fairly low well density in the center of the island, and then you can have developed areas for very, very high well density, in particular along the coast. The purple dots represent water supply systems, which on Gabriola mostly are small 1 and probably maximum 15 connection water supply systems that are permitted to operate through island health. And these can range from small commercial facilities, restaurants, hotels, and clinics, those types of commercial, industrial, and institutional water supply systems. But there are no major service areas on the island or water supply, municipal type water supply or improvement districts. So when it comes to domestic water supply, it's mainly from private individual wells and in some cases shared wells. The colored map, the colored fill represents the vulnerability of the aquifer to seawater intrusion. So you can see that some areas in particular on the northwest part of the island have a fairly moderate to higher risk of intrusion of seawater. And therefore that should be something that we can think about when we're thinking about monitoring networks and data collection. Next slide. This is some of the work that has been done to look at recharge potential, or the ability of rainfall, if it were to be land on the ground surface, its ability to infiltrate and contribute to groundwater recharge. So you can see that in the center and higher elevation areas of the island are more likely to be where groundwater is going to infiltrate and become groundwater recharge, whereas on the coastal margins and in lowland areas, those have lower groundwater recharge potential and are more likely to be discharge zones. Next slide. So when we're thinking about groundwater monitoring methods, we can measure several things. So we've already had a really good overview of what that looks like in terms of monitoring of groundwater sources. For example, monitoring groundwater level within a well. We can also measure water use or demand. In the streams, as Ali and Sarah have talked about, we can measure level or discharge or flow. Of course, if we have climate stations or weather stations, we can measure parameters associated with that, temperature, precipitation, evapotranspiration, and those are really useful for water balance model development. On the quality side, the monitoring can range from simple field parameters that are measured with, say, a handheld unit, such as temperature, pH, or electrical conductivity. That can be done with these simple devices and doesn't require a lab test. And then we can have other tests that are required to where we need to send a sample into a lab. So microbiology, so testing for bacteria or viruses, geochemistry, including metals or major ions, drinking water potability, and then specialized sampling, including isotopes, hydrocarbons, or emergent contaminants. And I would say that probably on the last three of those are typically not done on a standard monitoring network scale and may be used for more specialized studies. Next slide. So why would we want to do monitoring or measurements of these types of things? So the first is that we want to understand environmental conditions. So we want to develop an understanding of, we may want to develop an understanding of what the background or ambient conditions are. We may, on the groundwater side, might want to see what's happening in terms of groundwater conditions in recharge areas versus in a discharge area. When we're thinking about freshwater ecosystems in a more holistic way, we can characterize the relationship between surface and groundwater by doing monitoring. For example, looking at the timing of flow and precipitation, the presence of base flow following long dry seasons, for example, often indicates a groundwater influence. And so we can look at those seasonal patterns and variations and try to understand what is happening within those systems. And then it's also important for us to be able to evaluate change over time. So both Eric and Ali talked about how when we conduct monitoring, the longer we monitor for, we get more out of it. We start to develop an understanding. Also, we can see where changes are starting to occur, whether that's to do to climate change or long-term climatic cycles, like the Pacific Decadal Oscillation, or impacts of water use or changes in land use. And then from a user perspective, it's really important to monitor to be able to better manage our water sources. So an individual well owner may want to collect information to help them know whether water is suitable for use, if it's potable, to identify if they need to be undertaking any kind of repairs to their well. If you have an agricultural well or a farm well, then it's your livelihood to have water. So you may want to monitor and be able to optimize their pumping and irrigation use and make sure that you have adequate quantity to cover your irrigation demands. Water systems monitor to be able to manage their supply and demand, to communicate with their users. They are required through their operational permits to ensure that water that they provide is safe for the users. And it's really helpful for water systems to monitors should identify early whether there are problems with their water source, for example, declining well capacity, a leak has happened, any kind of water quality concerns, and to ensure that they're prepared for a drought and to respond to periods of water shortage if those occur. And then there may be monitoring as a result of water license terms and conditions, so for either surface or groundwater license for non-domestic use. And of course, monitoring helps us to manage and look at the watershed and then identify the sort of regional trends and concerns. Next. So how much cost or effort that is involved in monitoring really depends on the purpose and the intended use of the data. So it can range from everything from fairly simple things that a domestic well owner can do, like measure how much water they use by looking at their changes in their tank volume. They can make note of qualitative things, like if they notice a change in the smell or a taste of the water, and they can do water quality testing. At the domestic level, oftentimes water level measurements are not taken, typically because of either cost things or knowledge, or maybe there isn't a need. There's a small number of users reliant on that source. And so if something, and if they have to go to another source, it's not as significant compared to a well that is serving a municipality. At the small water system side, I think that when I think about Gabriola, I would love to see small water systems undertaking more monitoring. So water use is sometimes measured through metering, or you can do proxy measurements through looking at tank volumes and such. Water quality measurements and using field parameters can be measured. The Island Health or Health Authority will typically require testing, fairly frequent testing for bacteria, but geochemistry is done on a less frequent basis. And Stacey Soa is here from Island Health, and she can answer any questions about that after in the Q&A. But and then so I would say there's some opportunities there, definitely, to think about water level measurement and measurement of things like electrical conductivity that could indicate if there's saltwater intrusion concerns. At the municipal scale, those municipal water systems typically have a more enhanced monitoring system in place. They have a higher budget and a higher population that they're serving, so they need to make sure that there's adequate supply and that's continuing on. And so they can provide a guide of sort of the higher level of effort. But still, simple data collection using a data logger doesn't have to break the bank. The technology is improving all the time, and it's more and more feasible for this type of work to be done. Yeah, you can go ahead. Keep going. Oh, wrong way. There, next one. All right, so we've already talked about the provincial observation well network, I think a little bit. Erica mentioned that, and that is operated by Ministry of Environment and Parks and Ministry of Water, Land and Resource Stewardship. There's 4 active observation wells on Gabriola Island, and the Regional District of Nanaimo has 2 of their volunteer observation wells. As far as I understand, there's no Water Survey of Canada or provincial gauging stations on the island, but there are some monitoring activities that are being undertaken by local groups, including Gabriola Land and Trails Society. Next slide. So that gives you an idea of some of the monitoring locations, including 2 historical hydrometric stations with the triangles, and the blue wells representing actively monitored provincial observation wells, and the volunteer observation well locations. So you can see that there is a good distribution of monitoring locations, especially once we consider the addition of the RDN volunteer wells. but there are some areas where we lack data, and those are in particular in areas where there's high well density and higher risk of things like intrusion. Next slide. Here's some of what the groundwater monitoring data can look like. So the provincial observation wells are dedicated wells. They have the data logger, which measures groundwater level and temperature, hourly readings. Several of the wells have telemetry for real-time data communication, and the data are published on Aquarius. The two wells down at the bottom are the data from the volunteer observation well network. You can see that there's been they were established in later in comparison to some of the longstanding wells on the island, and you can also see that in some ways the data signal is a little bit more what we call noisy, so it's a little more jagged, the hydrograph reflecting that the wells are in use. But you can see these types of long-term trends, and that on the island in general, within the monitoring wells that are currently active, we have stable trends, with the exception of some wells, such as observation well 197, which shows that it may have had some decline. Next slide. This just shows some of the monitoring that I believe that is being undertaken at Mella Creek, and it would be interesting to hear from local groups about the type of work that they're undertaking. Next slide. So what types of hazards would we want to be aware of? So in terms of water quality, of course, within the bedrock setting, so I'm talking focusing mostly on the groundwater side, we have natural contaminants like iron, manganese, fluoride, and arsenic, which are present in these fractured sedimentary bedrock type aquifers. Contamination sources mainly include non-point sources or diffuse sources, things like septic system discharges, agricultural waste, and those can increase concentrations of nitrate and phosphorus or contribute bacterial pathogens into groundwater recharge. Seawater intrusion, as I've mentioned, is a significant risk on the island, and that can be indicated by an increase in salinity and compared to background concentrations. And seawater intrusion, in addition to showing that occurring due to natural vulnerability of the aquifer, it can be an indicator that there's been unsustainable use. From the quantity side, the hazards that we might experience are locations or areas where demand is exceeding the supply. There can be deepening of groundwater levels as a result of groundwater pumping. And then, of course, we have a seasonal deficit because of short wet season and long dry season, which the length of which is increasing with climate change. Climate change and drought are things that we need to consider within the groundwater setting and overall. So we're seeing already changes in the time and amount of recharge that is occurring. It can increase evapotranspiration rates, and we're seeing these very long dry seasons through which we have to manage with the storage that has been accumulated over the winter period. In the seawater intrusion case at the quantity side, that can occur as a result of deepening of groundwater levels, for example, pumping of groundwater levels below sea level. Next slide. So this is just some data showing sort of long-term precipitation data from Nanaimo City Yard. So we can see that overall we are getting, although precipitation is variable, there does seem to be an overall annual decrease in annual precipitation. And definitely we see less precipitation within the summer period. Next slide. This slide also shows the trends in precipitation, monthly trends in precipitation. So you can see that there's a downward trend in the volume of precipitation received on a monthly basis in this data set from 1970 to 2023, with the exception of January. So we may have some winter months where we have higher precipitation, but overall during the year, we're seeing trend toward lower precipitation. Next slide. So a little bit about saltwater intrusion and its mechanism. So as I've mentioned, the seawater in an island setting, freshwater has low density and it sits as a lens overlying groundwater with a higher density. There's a transition zone in which there's transition between the fresh and saline water at depth. And that transition zone can vary both seasonally in response to precipitation and recharge and discharge patterns, as well as tidal flux and other events. With the climate change, we are expecting potentially increase in seawater intrusion hazard and risk, both due to sea level rise, increased anticipation of storm surges and overtopping or wave overtopping events, which introduce saline water above the aquifer. As well, well drilling can impact or contribute to seawater intrusion. For example, if wells are drilled deeper into the saline zone or intercepting saline and interconnecting fractures which contain both saline and fresh water, and where the well becomes a column for mixing between the two sources, as well as pumping effects. So if we overpump, or in areas where there's a high density of wells, that can cause a movement upward or inland of that freshwater saline water interface. Next slide. When we're thinking about water quality indicators for intrusion, we speak in terms of operational thresholds. So total dissolved solids of 700 milligrams per liter, electrical conductivity of 1,000 microsiemens per centimeter, or chloride of 150 milligrams per liter is considered a threshold indicating that the well may be impacted by seawater intrusion. And this level is the level at which you might start to investigate the potential causes of intrusion or whether the well is being impacted and why. In comparison, the guideline for drinking water quality is slightly higher, and for example, 250 milligrams per liter chloride. And at that concentration, the water will have a noticeably salty taste. The lower thresholds are recommended because they're preventive and indicative, so action can be taken before significant impact has occurred. Next slide. So just to give some example of how we can use data to understand what is happening in terms of impacts. This is an example of one of the Regional District of Nanaimo volunteer observation wells located in Cedar Yellow Point. So it's not on Gabriola Island, but it's the same type of aquifer as we have on Gabriola Island. And the data logger has a logger that measures not only water elevation, but also electrical conductivity, which is an indicator of water system salinity. And what we observed from the patterns of monitoring over a long time period, over a decadal time period, is that as the groundwater pumping level declines below sea level, you have an increase in electrical conductivity. So we may see similar things if we would be undertaking this type of monitoring on Gabriola. This site is located about 25 meters from the seashore. So that's important. And it's a domestic well, so there's low water use. Next slide. So here's another one from the same aquifer, which is a water supply system well, and they've had long-term monitoring of chloride. Interestingly, this well is located 375 meters from the shore. So it's not what you would typically think of waterfront property, but yet over time, as a result of continual use of the well and the chloride trend has been slowly increasing, and it's approaching that operational threshold that we talked about. The good thing is that because they undertake monitoring, they've been able to communicate with their water users and to get them to reduce demand, and that has somewhat improved the water quality. So that again shows the value of monitoring things like water use and the water quality. Next slide. So the Islands Trust produced the Freshwater Sustainability Strategy in 2021, and improved data management, monitoring, and inventory of water resources were highlighted as key actions to be undertaken as part of the freshwater strategy. Also, as in relation to this official community plan processes, the effort or the intention is to try to integrate water availability and vulnerability information into land use decisions and policies and regulations. So that's an important piece. And as Erica alluded to, that connection of science to behavior and to changes in policy or actions. Next slide. So when we're thinking about data gaps on Gabriola Island, I think that it becomes present that in terms of water quality, we actually have fairly limited data collection at present. And I think that that's one of the key things that we have an opportunity to improve, in particular through the small water systems and the data that are collected as part of their operations. Also, I think that it would be useful to have more groundwater monitoring near the coast and in areas of high well density, and that's been highlighted by many community members as well. Surface water, I think that having some input from local stream keepers and the folks involved in terms of what the needs are for monitoring at that level would be really helpful to understand what the possibilities are there. And water demand data is something that across the board, across the province of BC province, and in many areas, it's often one of the biggest data gaps that we face, and it hinders our ability to really understand where water is being used and how much and to be able to educate or change behavior. Some of the things that we need to consider are some of the things that have mentioned already, in particular the standards for data quality that we want to collect, the need for review and quality assurance and quality control of the data, where that data gets housed, and things like privacy concerns. There's lots of examples of public data places where data are shared, including the Aquarius, where the PGON data and the Volunteer Observation Well Network data are stored. Living Lakes is another program from the Kootenays that store their data on Aquarius. Depth of Water is a program that GW Solutions has developed for data management. And then there's some public open data source programs like Data Stream. And a really neat example is the Saltwater Island or Salt Spring Island Freshwater Catalog and the data that they're collecting and sharing. So you can next slide for that. So this is really cool. The Pacific Data Stream, funded by the Gordon Foundation. You can see that there's numerous sites on Salt Spring Island, sort of on the central right part of the screen. And those are data that are collected by community groups, including field parameters, temperature, and flow, and they're contributing into the knowledge, and those data can be downloaded and used by other researchers or folks working in the area. Next. So we've gone much longer than we anticipated to our question and answer session. I'm not sure if we want to take a break or whether we want to launch into our panel. To get us started, we had some questions here, and William, maybe our panelists will join back up.
Yeah, I think we can. It's 3 minutes to 5:30, so we could just take a short 3 to 5 minute break and then get the panelists on and stop screen sharing, and then we can get into the question and answer session.
Nice.
And yeah, please, if you do have a question, you can put it into the question and answer component of Zoom. We've had some come in, so I know that's working.
Yeah, maybe we could start like through 5:30. Does that make sense? 2 minutes?
Yeah.
I would be interested to know in the chat or in the Q&A, where folks are coming from. And, you know, the things that folks are involved in, or oh, I see that. Thanks for confirming that the water use survey has been extended.
Yeah, so there's a little bit of feedback. The water use survey has been extended to May 20th.
May 20th. That's
Yeah.
good to know.
Yeah, and yeah, I think, Sylvia, I'll run this idea by you in real time, but people can put question answers in the chat, but there's also a function that people can also speak their questions in that. That might be effective. So if someone would like to ask a question via your microphone, you can raise your hand, and Chloe behind the scenes will make it happen. And I encourage you to keep the questions brief so we can have enough time for the answer from the panelists. There has been several questions that have been sent in, so I think we'll start with those, and then we can move on to audible questions after we get through a bunch of text questions.
Sure. And are we going to use any of those ones from the presentation? Do we want to show those or something?
Yeah, I think I will like ask them. I have them in the queue. Yeah. Well, I think that we can get going. Hopefully, we've had enough time for a little break, and yeah, we'll have a stop at 6 o'clock, so we have a good half an hour of question answers, and yeah, should think everyone has introduced themselves except for Stephen. Would you like to introduce yourself, Stephen?
Sure.
Okay.
Thanks, Blaine. Oh, so other Stephen probably.
Oh, both.
Yeah. Two Stevens.
Okay, so I will introduce myself anyway. I live on Gabriola. I have a well. I drink water. But I've also done some research here on groundwater. This was about 20 years ago, but we did a regional groundwater sampling program looking at groundwater geochemistry. One of the focus of that was fluoride levels, because there is an issue here. But we also looked for evidence of groundwater or saltwater intrusion at that time. And it would be an interesting exercise to take the wells that we sampled back in 2000 and whatever it was, 1 or 2, and see how they have changed in the 20-something years, because we have that data from back then, and we could relocate those samples. The wells were probably still there. Anyway, I'll leave it at that.
I like that. That sounds like a cool idea.
And the other Stephen.
I'm not a water expert, but I'm a planner with Islands Trust and working on the Gabriola Official Community Plan Review with Narissa Chadwick, another planner, and so thanks for letting me introduce myself.
Yeah, thanks for joining us today. Very important component is to connect this work with planning services, of course.
Is Antonio still there?
Oh, yeah, there he is.
Yeah. Hello, good afternoon. Antonio Barroso. I'm a hydrogeologist and I'm working on the freshwater footprint with Sylvia.
Great, thank you for joining us, Antonio. Okay, so I think we can get into a few kind of warm-up questions from just on the a general like freshwater sustainability program perspective, and this was one from the presentation that we had. So what are the most significant or important data gaps that we need to fill to better have for better freshwater management and protection on Gabriola and other islands?
Maybe I'm interested in Steve, like, or someone who does the surface water stuff, or.
Well, I can answer part of that question, at least from my perspective. There are three sources of water here on Gabriola. One is rainwater that people collect off their roofs. The other is well water, but there's also a significant amount of water that is trucked in from Vancouver Island. And when I say significant, I don't know how significant, because we don't have any data on how much water is brought to Gabriola, where it's coming from, and where it's going to. And I think if we were able to start collecting that data, it would help us know how much water is coming in and to what parts of the island it's going, because those are areas that have water issues. It also helps to know, or will help to know, where it comes from, because there's no certainty that we can count on those sources of surface water on Vancouver Island, like the city of Nanaimo, into the future. They could stop providing water to Gabriola anytime they want. And so it's important for us to know about how much water is coming, where it's going, and when.
Stacy, it looks like you.
Yeah, this was so somewhere where, like, I feel like there's not necessarily a gap, but like a gap in the connectivity of the data. So, like, for example, I saw on one of your slides, Sylvia, about the types of water quality data that Island Health has access to, but making that publicly available, or sharing it out, even for good work that's being done, like the different projects that have been talked about here, can be difficult, because technically the water system supplier owns the data. Like, we use it to interpret, but we don't always have good ability to share it out readily. So it can be a little bit of a barrier. So having that more transparent accessibility to data would be really, really key. And I don't know, it may be in places like Gabriola, it might just be talking to operators and asking, like, are you open to this data being shared? And let's just get it rolling, rather than working through the red tape of FOI requests and everything. So, like, those data points are there. And to sort of highlight what Stephen's saying, we have anecdotal information about, over the last couple of years, we know trucked water has like doubled or tripled in terms of how much is going to the island. I do think that the way that the city of Nanaimo tracks the fill station would likely allow us to see where the trucks are, or which trucks are filling up, and then where they're going. And I'm sure that we could coordinate that. But again, it's just one of those, like, it's just the lack of connectivity that we don't have that happening yet. So if we can get everybody on board with it, I think it would actually be fairly easy to get some of that data.
Yeah, on Salt Spring we have ferry cams on our ferries, and someone could just sit there all day and just count the trucks coming onto the island.
There you go. Yeah.
Yeah, I not to divert too much away from where water comes from, but I like Stacy was talking about like, how do we share data in that interface, and that brought me to some questions that are coming up during Erica's presentation, and seeing all this data. And it looks like it's a mountain of data. And I imagine you can't take millions of data points and just throw it at the province and that works. So I was wondering, like, from like kind of source of monitoring to its final destination where it's making decisions. Can you speak a little bit to that intermediate part? Like, does the RDN have their own way of managing all that data, and then does it get processed and go to the province? Because I believe it was Sarah was speaking that some of the data in the real-time program isn't completely vetted, and I was just wondering how the RDN works with that intermediate process. Thanks.
Yeah, that's such a good question, William. And it's something that I think each of our separate monitoring programs has very separate solutions for. Like I just highlighted today, you know, in terms of groundwater data and how we manage that a little bit, and our surface water quality data that's uploaded to the environmental monitoring system with the province, which does need to be vetted and goes through a bit of a QA/QC process. But there's many more, and kind of all this like patchwork of sort of data management approaches we've taken over time. Like one of the monitoring programs I didn't even really have time to mention is we collect groundwater quality data through our rebate program. So when residents want to access rebates for understanding water quality in their wells, they are able to, you know, check a little box to say they're comfortable with sharing that with us. And that's all, you know, that's managed on like water tracks. It's an external sort of database. So each of our programs, monitoring programs, kind of depending on sort of the costing out of it and things like that, has sort of kind of evolved to meet the needs and the growth of that particular monitoring program. But it's certainly a challenge, because I think that, you know, data management it's an expensive endeavor, and I think that Sarah, you pointed out so eloquently that, you know, data collection is a tiny sliver of that, and it's actually the processing of it and the managing of it and then the sharing out that is often not really considered in that full data to action cycle, and sometimes yeah, it's a bit of an invisible part of it, so it's not as easy and readily to fund sometimes, or to bring people on board to partner with necessarily. It's hard to explain to people the complexity of that and the cost of it, and all those types of things. So yeah, sort of depends on each monitoring program, but yeah, kind of has evolved with the program.
Yeah, I've often thought that with the islands, and Gabriola is somewhat of an exception because it's relatively close to Vancouver Island and a larger community. But I think that developing local networks and local champions that are involved in the work would be a cost savings in a lot of cases, especially for islands like Saturna or Maine, where it's very hard to get to. You see that in the provincial observational networks tend to be fairly sparse on those islands, and there's very limited information that we have. And, you know, similarly up north on Cortez and that sort of thing, there's no monitoring. So having local champions, I think, would benefit those type of monitoring programs if there was funding or something that could keep it going, you know?
Erica, not to push the envelope on this one, but I mean, I'm really interested in groundwater monitoring because it's a continuous data set, and it can generate a lot of information, a lot of data at one time, and there is a need for local groundwater monitoring on the islands, and indeed the reason why the Freshwater Footprint Project was chosen to have Gabriola as a case study is because of it's likely the most data rich island in the Islands Trust area because of the RDN's Drinking Water and Watershed Protection Program and other efforts on the island. So there aren't islands that have the regional district stepping up and doing the work or have the infrastructure to do so. So yeah, my one question about that. So specifically to groundwater monitoring, is there like an intermediate program database that RDN has invested in that is facilitating, like moving the data to the province for their use in adjudicating water resources? But also I noticed that you have like really nice graphs, and I'm just wondering, like, are those graphs updated annually, and how is that process? Is it a big undertaking, or because of the investment in software and stuff, it's kind of now being more streamlined because you're halfway through your 10-year plan? So yeah, thanks.
Yeah, no problem. Yeah, it's a good question. And I think that the evolution of it, I could actually even ask Antonio to jump in and speak to it a little bit, because I know he's been involved in some of this even longer than I have. But, when we initiated that program, a lot of the uploads that we were doing from our groundwater wells was just uploaded into Excel databases. And our poor monitoring coordinator had her computer crashing all the time trying to just visualize that data. So we did turn to an external consultant to sort of build a database management system for us to kind of house a lot of that. And so Sylvia pointed out the management system Depth to Water, which has been really advantageous for that. We also use Aquarius for kind of cleaning up some of that data to create those visualizations, but we don't have the capacity to do that on a continuous basis. Some of those provincial observation wells, they have telemetry associated with them, so you're able to get that real-time data essentially of what you're seeing with those changes in groundwater. But the nature of a volunteer observation well network, it's been very expensive. We can't really install telemetry in a lot of those systems, so it requires really like boots on the ground, people going out and doing those downloads and then uploading it into those databases. And we really only do that visualization and cleanup once a year. So I mentioned in my presentation that kind of pre-summer groundwater level analysis. It was identified that that's the time of year that would be really good to share this information out across the region, heading into that season. So we kind of get that snapshot that can help inform some of those summer management decisions. But the way we try to present that is looking at the full year behind us. So that's kind of the way that we try to present it out. But I will say it's time intensive to produce those and expensive from sort of a staff time perspective. We've looked at the possibility of installing telemetry, for example, but it's not really feasible for those wells. And even just like the cleanup, as Sylvia kind of showed, comparing those provincial observation wells versus those pumped wells, like cleaning up the data a little bit with all that interference of every time someone flushes their toilet and the water level goes down, that shows up on those volunteer observation well hydrographs. So you kind of have to clean that up so you can read it a little bit better. But yeah, does that kind of answer your question a little bit about sort of the involvement and that data management?
Sure. Yeah, and this is not just my questions.
Yeah.
There are some very interested parties
Yeah.
putting their questions in, and one of them, and one of the questions here is like, this is a big monitoring program, and this is for others in the panel that have these large monitoring programs. I know that I've been on multi-million-dollar monitoring programs that have disappeared, like Cumulative Effects Management Association in Alberta, which is very sad. And so what are the biggest challenges for monitoring network data collection and management and the longevity? And I think that could be open to anyone on the panel.
Yeah, I could just jump in to sort of start. I think a big part of it is funding, figuring out kind of who's going to hold the reins and establishing a long-term funding source. We've been really lucky with the RDN's DWP program. We're funded through like a parcel tax, so we have that longevity where we can kind of plan out for the future of how we're implementing that action plan, and then kind of look at where we want to prioritize data collection and filling in those gaps over the long term. But yeah, funding is a big part. And then also, honestly, like volunteer burnout can be a big one as well, or volunteers no longer able to contribute. We see like the volunteer base, especially in some of our surface water quality programs, they're retired folks, and they tend to, after a certain point in time, they can't climb down into the streams necessarily and actually collect that data. So it's sort of who we're engaging in the community, and that sort of like long-term view can definitely be a challenge. But yeah, that's sort of what we see in our programs. But yeah, if anybody else has anything to add, for sure.
Yeah, I'll jump in and definitely second what Erica said, that funding is definitely kind of one of the major challenges associated with our program anyway as well. Like, especially kind of that longer term funding, because we can usually, get 1 or 2 years kind of commitment from folks, but then, longer than that, it's really hard to plan. And, we have a lot of groups that are now kind of relying on us, and we want to be able to expand and kind of make plans for the future. And, kind of not knowing how much, what our sort of capacity is going to be like year to year can be definitely super challenging in that regard. And then, yeah, same kind of with the volunteer burnout, like especially with something like surface flow monitoring that's, fairly intensive. People do it for a few years, but then, yeah, maybe they get older, or maybe they, have other interests that come up and they move on. And, then we sort of have to train up new people. And so definitely kind of trying to recruit some sort of younger volunteers sometimes can be helpful. People who are maybe like a little more tech savvy and kind of interested in that side of it, to sort of support older volunteers who may be less interested in that kind of side of it. Could be also very helpful. So we have been kind of trying to incorporate that a bit into our program, of like ideas of how to kind of recruit new volunteers, and specifically volunteers who are interested in flow. There are lots of volunteer groups who have lots of members, but maybe not all of them are super interested in flow, or really, maybe know how it's done and that type of thing. So yeah, those are sort of the key challenges. And also because equipment's expensive, having funding to actually purchase things like flow trackers, and stuff that we kind of use on a regular basis and need to be able to loan out is also really key.
Yeah, thanks for that, Ali. Maybe a question for you. Are there some monitoring strategies that can be easily implemented, like that doesn't really require like going to a equipment library or something like that?
Sure, yeah. It really like kind of depends on what folks are interested, like in terms of flow monitoring. Like, I know on Gabriola there's maybe sort of fewer, large streams. Like I'm not super familiar with Gabriola, to be honest, but I believe it's more sort of smaller, maybe more ephemeral streams that are definitely kind of more seasonal. Sort of monitoring that people are interested in. So things like doing bucket fills, we call them volumetric measurements, where you can actually, if you have a culvert or like a weir or step or something that you can actually like fit a bucket under, and record the time it takes you to fill the bucket, and then how much volume of water you're actually filling. You can get pretty good discharge measurements that way. Actually, we have a couple small streams that that's kind of the only way we can monitor them in the summer. And uh, we've tested it against the more expensive like equipment like flow trackers, and actually got like incredibly similar results. So they're pretty good method to use, and they really just require like a bucket and a stopwatch and a little bit of math, and you've got a discharge measurement. And then there are things like installing flumes that you can do in smaller streams. I'm not very experienced with those methods, so Sarah maybe could speak to those, but that's also something that folks have used in these kind of smaller streams for more seasonal kind of flow analysis.
Yeah, additionally, depending if you're not necessarily interested in the number itself and more just to put more of like a bit of an overall descriptor, like just noting presence, absence of flow in streams, like putting trail cameras up and taking, like a daily photo and seeing, oh yeah, this is when these streams have dried up, and has that changed through time over years. Some of that data can be very handy, I think, for these things where you do have a really small volume if you can't get good measurements. So I think that's some things that people can do quite easily. And yes, with flumes, they really just take a bit of effort to install them, and then it's just coming by and taking small measurements, and it's something that can be done easily. And I know the province does have quite a few extra ones around if there are folks that do want to try it out. That certainly can be lent out to folks. So,
What about staff gauges on some of the wetlands or things like that? Is that useful, or?
I would assume water levels through time. I'm not an expert at lake levels or anything to that extent, but very easy thing to install, and it would take basically, if you're just establishing maybe a benchmark network to make sure the staff gauge doesn't move, again, like just volunteers coming out and reading a staff gauge, and there's many staff gauges available. They can be very cheap. It really costs very little, like $10 for like a plastic one, you know, so those are definitely things that can happen and people can do very easily.
Looks like Steve is.
I'm concerned that in this climate of climate change, we don't have enough weather data. There was a Environment Canada weather station operating on Gabriola up till about 2017. It's now shut down. I noticed there was an RDN station down at the east end of the island. I don't know anything about that. Maybe Erica can say something, but there's nothing on the west end of Gabriola. And so without any good credible climate data, it's going to be hard for us to really understand water supply issues in the future.
Mm-hmm.
Yeah, I can't comment on that one. That may have been through parks, but that's something we certainly see just kind of zooming out for like regional monitoring, that's been a consistent recommendation on our monitoring programs to get more weather data, because we really live in a region where it can be very localized as well in terms of weather patterns. So it's sometimes really hard to do that comparison of like when we have groups out taking like a turbidity measurement and things like that. Like, was there a recent rainfall event in that particular area? And if we're kind of comparing it to a weather station that's sort of like 2 basins away, it could be actually a very different story. So yeah, certainly agree. And that's something we're kind of looking into a little bit as we kind of look at strategically planning out what we're doing with our monitoring programs of maybe collecting some of that weather data would be really advantageous to kind of calibrating against what we're seeing in stream flows and water quality as well.
Just to add to that, Steve, that station actually is only air temperature and barometric pressure. Doesn't have any other data, and that data is used to compensate all the other volunteering observation wells in that area. Environment Canada will measure other parameters, right? Rainfall and precipitation, but the RDN station doesn't.
Right, and so the nearest weather station to Gabriola is Entrance Island, which is off the coast even further, and it has quite a different climate than we have here. We tried to get Environment Canada to keep that weather station that was here going, but they refused. So if somebody like RDN would be interested in creating a weather station, I think it'd be really useful. It's critical, I think.
Yeah. And I was going to say that the GW Solutions has some experience installing this type of weather stations in some remote areas on the west coast of Vancouver Island to augment federal systems for First Nations monitoring networks. And an observation was that often those networks, the Environment Canada networks, were at lower elevations. So having that higher elevation kind of upper watershed monitoring was critical and really needed to understand what was coming into the system.
Yeah, that's a great point about where the weather stations are indeed. And also for groundwater monitoring, we've noticed on Salt Spring that monitoring the highlands and the lowlands was very effective in understanding the system, as they operate very differently in the recharge and discharge area. So just a point of order here, we are a few minutes to the end of our meeting, and we do have one attendee that has their hand up, John, and we'll get to John in a second. I just wanted to acknowledge that there has been a lot of questions about rainwater harvesting and policy and a lot around strategies around regulation of water, and we appreciate those questions and we're logging them. We are having another workshop as part of this project on May 29th in person on Gabriola Island from 3:30 to 6:30 in the Heron Room at the Haven. And in that workshop, there will be the opportunity to engage in those kinds of questions. We're naming the workshop defining freshwater footprint. So how how do we approach this? And so it's going to be questions that are more focused on that, where the intention of this workshop was to be more focused on community monitoring and more the technical nature of doing so. Before I close it out, we have John, if you would like to ask your question, go ahead, if you're still there.
Can he be unmuted? Is that?
I think he should be. Chloe, maybe you have to unmute him. Oh, so again, the time. Yeah, just thank you, John. I think you're ready to go. I just wanted to confirm the workshop is May 29th from 3:30 to 6:30 p.m. in the Heron Room at the Haven. Okay, go ahead, John.
Well, first of all, I'd like to say, whoever made all those maps, there's some fantastic maps that I've never seen before. And I would like to see some way to get them into public circulation on the island. Huge help. Secondly, there are some big problems in terms of changing connectivity in various different places. And there needs to be some discussion about, is this saltwater intrusion or is this something else happening? What about the argument about old water? In many cases, I think we've drilled into pods of old water, but I don't know how to prove it. But when you have a salinity changing 2 kilometers from the ocean, why?
Yeah, I'm aware of that too. And I do believe that there are some zones. For example, I've seen data in sort of village area where the wells are completed above sea level. So the depth of the fractures are above sea level, but the wells are more saline. And it is common within these aquifers both to have elevated salinity due to maturation, so interaction of the water with the rock materials, and also have zones of water that has been trapped in the formation during periods of higher sea level. So after the last glacial period, sea levels were around 100 meters higher than at present. So there is potentially relic seawater trapped in formation. So even if it's not an active process of drawing seawater into fractures at the coastal zone, where we have elevated salinity or changes from fresh to saline conditions, I think it is an indicator that there could be unsustainable use or impacts both of drilling into deeper zones or overuse or drawing down the water level. So I agree with you, John. I think it's something that we need to examine further and have more data to understand what's happening.
And it occurs to me that one might come up with a possibility that would say you need a policy, you can't drill deeper than a certain depth.
Yeah, and John, that's an interesting point, because and again, we can just describe this more at the next workshop, that in other jurisdictions there are drilling authorizations, and like you said, there are some licensing limits on how deep drills can go, and those are really interesting perspectives on the governance around groundwater that doesn't exist in the Water Sustainability Act or the Groundwater Protection Regulation, and I think the Water Sustainability Act is flexible enough to grow over time and incorporate those concerns with area-based regulations. And we've heard about that from the province about area-based regulations, and they haven't really been implemented, but it's a possibility. We are out of time, and I appreciate everyone who has joined us today, especially staff. Thank you for Islands Trust staff, and thank you to the provincial staff, regional district staff, and NGO staff, and residents and our consultants. I really appreciate everyone who is involved in this, and I think this is a great way to approach projects like this to try to get some diverse voices from the community and for us to share information. And I think that all of the organizations on this panel do have that part of their mandate. And this is great that we can coordinate that all together in one spot. So with that, is there anyone else that would like to say something from the panel?
Well, I guess I'm curious about where we want to go from here. But I guess it's the start of a discussion. I see it as a start of a discussion rather than an end point. And I'm hope that we've inspired folks a little bit or got people's brains thinking about what the possibilities are. And I really thank all of the presenters and the very interesting information that was shared, particular with Erica, Ali, and Sarah. And yeah, for the people to take the time out of their evening to come and listen to it, talk about water. And then maybe you can share, will this presentation be available that people can see it, or maybe the folks that weren't able to attend today?
Yeah, so the presentation has been recorded, and also if the presenters allow their PowerPoints can be shared. And also, since our next session on the 29th will be a longer forum, that there'll be a section where we can talk about how the community gets involved, and I'm sure we'll talk about more of the policy around trying to implement community watersheds and watershed monitoring and groundwater monitoring, and hear from local experience about that. And I'm always interested in wetlands, so looking forward to hearing the local perspective at our next gathering. So
Great.
Yeah, with that, I think we should honor our time. 5 minutes over, perfect. Thank you so much, everyone, and have a wonderful evening.
Thank you.
Thank you. Good night, guys.
Thank you.
Thank you.
Bye.